again to the Oval Academy of Education. Oval Academy of Education. Today we will start ICSE Class 7 Chemistry Chapter 4 Atomic Structure. In the earlier video of this chapter you have done atomic number and mass number. Now for a revision purpose I am again writing it here. Atomic number is denoted by Z, it is number of protons. Mass number is denoted by A, it is number of protons plus number of neutrons. When we write the atomic number of any element, atomic number is shown as subscript and mass number is as superscript. Right? This is mass number and this is atomic number. This is atomic number is a subscript and mass number is a superscript. For example, if I want to write configuration of sodium, I will write it as here 23Na11. What does 23 shows? It is mass number and 11 is atomic number. Right? Mass number means number of protons plus number of neutrons, whereas atomic number means number of protons. Right? Now if I want to write configuration of oxygen, I will write it as this shows mass number A and this shows atomic number Z. Right? Mass number means number of protons plus neutron and Z means number of protons only. Right? So here your brainstorming questions are: an atom has 4 protons, 4 electrons, 4 electrons and 5 neutrons. What is the atomic number and mass number? Atomic number Z is equal to number of protons. So how many protons are there? 4 protons. So there Z will be 4. And what is atomic number? Z is equal to 4. Mass number A. Mass number is number of protons plus number of neutrons. How many protons? 4. How many neutrons? 5. So mass number will be 5 plus 4 is equal to 9. Right? Now next question we have given: how many protons, electrons and neutrons are present in the following atoms? Also indicate the atomic number and mass number. Right? So first is 1608. So already this is atomic number, this is this is mass number, this is atomic number Z. Right? Now what is mass number? Number of proton plus neutron. And what is atomic number? Number of protons. Right? So he has asked how many protons, electrons and neutrons. The protons are 8. Protons are 8. Right? This is proton plus neutron. If we minus it, there we will get number of neutrons. The number of neutrons 16 minus 8 is equal to 8. Right? Now number of electrons, number of protons is equal to number of electrons. Number of protons equal to number of electrons equal to, if proton are 8, electrons will also 8. In the same way, you can find out the remaining answer of the remaining B, C, D and E. Right? Now we move on to the next portion of it. Now we know this is nucleus. Every atom contains protons and neutrons, right? And these protons and neutrons are made up of smaller particles called quarks. Quarks, right? These quarks are held together further by gluons. This will you study in the next classes. Right? Now one amazing thing is proton, neutron and electron. That makes an atom are just 3 of 200 subatomic particles. Amazing is what? That are not known yet. Right? You have to find out 197 more subatomic particles. So if you go further, move on to research in chemistry, this could be your area of research, these 197 particles. Right? Now this was just for your GK purpose, general knowledge purpose. Now we move on to our course, that is element. So element, simplest form of a pure substance. It is simplest form of a pure substance that cannot be divided into any other simpler substance. So element is the pure form, simplest form of a pure substance that cannot be further divided into. Right? What is their identity? They contain similar kinds of atoms, identical in all respects. Their main feature is they contain similar kinds of atoms which are identical in all respects. Example here we will take, good example is oxygen, O2 gas. It contains O plus O, similar kinds of atoms identical in all respects. Right? Oxygen atoms. Now we will move further. Compound. Compound is also a pure substance made up of two or more. Here similar, here two or more elements. Chemically combined in a fixed ratio by weight. Their weight will be fixed, right? So best example you see, you know, that is water. Water is H2O. Here mass of hydrogen is equal to 1. Mass of oxygen is equal to 16. That O2 16. Right? Now we write it as here HO H2 ratio O. 2 into 1, 1 oxygen, mass number of oxygen is 16, right? So it will become 2 ratio 16 and 1 ratio 8. It fixed ratio. So water contains fixed ratio of 1 is to 8. Fixed ratio of hydrogen and oxygen, that is 1 ratio 8. Right? Configuration or diagram of the will become like this. This is oxygen, this is hydrogen. 1 molecule of oxygen, 2 of hydrogen. Right? So this was element and compound. Now we move on to chemical symbols. Chemical symbols are the symbols we use in chemistry to represent the elements, right? Symbols to represent the elements, right? So earlier they were used in photographic sense, symbols like this. This was yellow, gold, for sulfur, some symbol like this was used. But when John Dalton came, John Dalton was the first to give figural representation of elements, right? He do this by his Dalton's atomic theory. Dalton's atomic theory you can read in your book. Matter is made up of tiny particles called atoms. We define atoms. Atoms are indivisible, they can't be further divided. Atoms cannot be created and destroyed. No one can create them, no one can destroy them. Atoms of same element are identical in mass and other properties, and different are different. Atoms of different elements are different in mass and properties. Now, after John Dalton came J.J. Berzelius. After John Dalton came J.J. Berzelius. J.J. Berzelius. What did he do? He introduced modern system of naming elements by their symbols. Today we see different types of symbols. They were given by J.J. Berzelius. So he made their basis of their starting letter. Starting letter or their first two letters. Right? For example, if we want to write cobalt, we use its first two letters O. If we want to write osmium, we use OS. Right? Now, these two letters, here is also a story for this choosing those first two letters. Why not only first letter? Because before starting this, carbon and oxygen were already named. So he has to choose first two letters. Right? So some were derived from their English names, some symbols were derived from the Latin names of the elements. English names for hydrogen we use H, helium, He, lithium, Li, nitrogen, N, oxygen O, chlorine F, like this, sulfur S, chlorine Cl, argon Ar, calcium Ca, manganese Mn, nickel Ni, zinc Zn, bromine Br, krypton Kr, iodine I, barium Ba, radium Ra. Right? These are all given in your book. From Latin names like sodium. Latin name of sodium is what? Natrium. We use Na of it as symbol. Right? Potassium, K, kalium, potassium, K, first letter of K. These are easy in learning. They are some difficult because you have to do their Latin names also. This is given in your book. iron, from where ferrum, Fe, we use Fe, like copper, cuprum, Cu, silver, argentum, Ag, gold, aurum, Au, mercury, hydrogen, Hg, lead, plumbum, Pb, tin, stannum, Sn, tungsten, wolfram, W. Right? These are you can do from your book. Now we have given these symbols of elements. So what does they denote? So significance of symbol. What is significance of symbols? They show name. First of all, as we know, they show name. Second, and they show an atom of element. Right? Convenience. To write the name of element instead of writing full name, we can write their symbol only. Requires less time and space. Sodium is big. Sodium is a big. We can write it as Na. For sodium, we can write N. So these are their some significance. Right? This was journal. Now, students, if math and chemistry, math and science subjects are easy if you have done their basics right. Right? They are scoring, give you more scores, and let's study. Now we will do the next part, atomicity. Atomicity, they are beginning from atom. So what atomicity shows? Number of atoms. Number of atoms present in a molecule of an element. Number of atoms present in a molecule of an element. Right? Element, what is element? An element is the simplest form of a pure substance which cannot be divided into simple substance, which cannot be further divided, or number of atoms present in a molecule of an element are atomicity. Right? Now, this atomicity has further steps. Now, two or more atoms can combine of same kind. Can combine, same kind can combine to form, what will they form? To form a molecule of an element. Right? Two or more atoms can combine to form a molecule. So, element. Molecule of an element. Now here same kind is very important. Same kind, for example, if two molecules of hydrogen combines, they form hydrogen gas H2. Two molecules of chlorine combines, they form Cl2, chlorine gas. If two molecules of bromine combines, they form Br2, bromine gas. If two molecules of iodine combines, they form I2, iodine gas. Two molecules of nitrogen combine, they form nitrogen gas, and this is so on, right? Main thing here is they are of same kind, same kind, same kind, same kind. Now here they contain only one atom, one atom, one atom, one atom, one atom, one atom. So they are called monoatomic. No, sorry. Here you can't say them monatomic. Monatomic will do in the next. Now can, here the concept is same kind. Now can different kind also, different kind. For different kind, like example is water, right? H2 plus O. So same kind, different kind. Okay, right? Now in this atomicity, we may have monoatomic molecules, and diatomic molecules, triatomic and tetra. Right? Now these monatomic molecules, they exist in isolated form. Isolate, they remain isolate. Example is helium, He, we can write, neon, Ne, argon, Ar, and krypton, Kr. These are all monatomic molecules, right? These are monoatomic, these are all polyatomic. They contain only one, they contain more than one molecule. These polyatomics are divided into di, tri, tetra, penta, right? So di, they contain two atoms combined together. Two atoms combined together. H plus H becomes H2 hydrogen. N plus N becomes N2 nitrogen. O plus O becomes O2 oxygen. Cl plus Cl becomes Cl2 chlorine. Triatomic, simplest example is O plus O plus O, that is O3. We call it as ozone gas. You all are familiar with ozone gas. Now tetra, like tetra means 4, phosphorus, 4 P plus P plus P, they become P4, phosphorus. So students, this was atomicity. You do it more carefully, it will come more and more times in this chapter as we proceed further. Right? Now we will move on to the periodic table. So what is a periodic table? Periodic table is a chart or table in which all known elements are arranged in such a way that the elements with similar properties are grouped together, right, in the same vertical column. In the same vertical column, elements with the same properties are grouped together in the same vertical column, and these similar elements are separated from each other. They are separated, right? These are their groups. Now these are periods. Horizontal rows shows periods. These are 7 in number, and vertical columns are 18 in number, right? What these vertical groups are used to write down their electronic configuration and to calculate valence electrons and their valency, right? Here these are 18 vertical groups, 7 horizontal periods. Below are lanthanides and actinides. Here you will see 1A, 2A, 3B, 4B, 5B, 6B, 7B. These are given 8, 1B, now again 1B. B is here, second B, third A, 4A, 5A, 6A, 7A, and these are 0. So there are many many questions would be arising in your minds. Why are these written? 1A is here, again A is here, why they are not in A series? These are big questions which you will deal in your higher classes. Here you are only to understand the structure of the periodic table, right? Why lanthanides, actinides are there, why this has given 0, why these are 7A belong to which inert gases, right? So here you have to only understand the structure of the periodic table and its importance. What is its importance? Its importance is it has systemized the study of elements and thereby making it makes elements simple and easy. Study of elements simple and easy as elements with same properties are grouped together, right, and different are in the different groups, right, and in the same way we can correlate their properties, which elements are having similar properties and which are having different properties, right? That you will learn in your higher classes. Here you have to understand only the structure of the periodic table and its importance. Right now, here these vertical groups, 18 vertical groups here, are used to write down the electronic configuration and calculate the valence electrons and valency. This you have to understand how to write the electronic configuration and calculate valence electrons and valency. We will do it in detail, right? Now here to understand how to write the electronic configuration. First thing, there are some basic things you should know. Number one is orbits. Orbits I have already explained to you. Electrons revolve around the nucleus. In definite energy shells. These shells are known as orbits. Right? So this is nucleus. These are four shells. 1, 2, 3, and 4. Right? So this is nucleus. Now this is K, nearest to nucleus. This is L, this is M, and this is M. And these are orbits where electrons are revolving. Right? Now number second is electronic configuration. Electronic configuration, the arrangement in which electrons arrange themselves in various orbits. Electrons arrange themselves in various orbits here 1, 2, 3, 4, 5, 6, 7, 8. This is carried to this can hold 2 electrons, this can hold 8, this can hold 8, this can 2. Right? This is a magic number you have to always keep in mind while studying the chemistry. Right? K, L, M, N. K can hold 2 electrons, L 8, M 8, and 2. 2, 8, 8, 2. 28, 82, K, L, M, N. You have to understand in this way. Now electronic configuration, electrons arrange themselves. Right? How they are arranged? 2, 8, 8, 2. This shell 2, this shell 8, this M 8 and 2. Right? So what is electronic configuration? Arrangement of electrons in shells. Right? Now third important thing is valence shell. Valence shell. The last shell is known as the valence shell. The last shell is known as the valence shell. In this, N is valence shell. Sometimes N is not there. These three are there. Then M is valence shell. 2 are there. Then L is valence shell. Right? Last shell. Now, number 4 is valence electrons. That, as we know, last shell is valence shell, and the electrons present in the valence shell are known as electrons present in valence shell are known as valence electrons. Right? So I have told you 420 elements which are in your syllabus. Right? First 20 elements of periodic table which are in syllabus. For these 20 elements, this magic number applies, a element 2882, right? Its details will be in your higher classes. Now we have to explain what are. So the this is the simplest representation which everybody can understand. This is first cell is K, second is L, third is M, fourth is N. K can hold 2 electrons, L can hold 8, M can 8, N can 2. Right? The shell which is closest, that is K, closest to nucleus, it has minimum energy. Now as we move away from nucleus, L, this has slightly higher energy than this, M more energy than L, right? And last shell is N. It has maximum energy compared to other 3 shells, but it can hold only 2 electrons. Now there is one rule you have to always keep in mind. Unless the low energy shell beginning from K are completely filled, electrons cannot move to higher energy. If it can hold 2, first you have to put 2 electrons in it, then move to next shell. If K is not completely filled, it cannot move to L, and if L is not completely filled, it cannot move to M, and if M is not completely filled, it cannot move to N. Right? Now we will move to, these were the basic terms. Now electronic structure of elements. What is this? Now if we study, you will study the periodic table. First element is hydrogen. Hydrogen, you have to keep in mind its atomic number. Number is 1. Right? Its period is 1. Now what would is electronic structure? You can show it by just putting 1 dot, as it is having only 1 electron, 1 dot. Right? Now second is helium. Right? Atomic number is 2. Electronic structure, 1 is for K. This 1 electron is K shell. Now helium is having 2 electrons. Suppose we want to total, this is nucleus, this is K, this is L, this is M, and this is N. Nucleus, K, L, M, and N. Right? Now 1 means we have to, if this is nucleus, we have to first fill K, that means here is 1 electron. In case of helium, K can hold 2 electrons, so we will put 2 electrons here. Right, this way. Now third is lithium. Its period is 2. And atomic number is 3. Now we have to move its electronic structure, make its electronic structure. So we write down here Kl, right? In K, first, this is 3. We will first complete K by putting 2 electrons there, 2 electrons. We have put 2. Now 3 minus 2, 1 is remaining, that will move to L. First we have to fill the lowest cell, K, then L. Now next is beryllium, Be. Its atomic number 4. Now Kl, first 2 here, then 2 are remaining, 4 minus 2. L can hold 8. First we will do. Right? Now boron, it's 5. So boron, Kl, K can hold 2, L can hold 8, maximum 8. So we have to adjust only 3. Right? Carbon, most abundant element on the earth, Kl. K can hold only 2, L can hold 8. We need only 6 minus 2, 4. We can adjust here. Right? Nitrogen, nitrogen is 7. Kl, 2, 7 minus 2, 5. 1, 2, 3, 4, 5. Right? Oxygen, Kl, 1, 2 are here. Only 2 K in K. L can hold 8. 8 minus 2, 6 are remaining. 6 will be here. 1, 2, 3, 4, 5, 6. Right? In the same way here, F9, nickel 10, you can adjust. Now period 3. In period 3, first is sodium. Sodium's atomic number 11. Its electronic structure Kl. Here K can hold 2. Remaining are 11 minus 2, 9. L can hold 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 2, 10. 1 is remaining, that will move to 10. Right? In the same way, period 3 has 3 shells. Sodium, magnesium, you can adjust 12 here. Aluminium 13. Bismuth, silicon, Si 14. Phosphorus 15. Sulfur 16. Chlorine 17. And argon 18. Period 3, 3 shells. Period 4, 4 shells. Now we will move on to period 4. Make this electronic configuration yourself to understand. This is your homework. Period 4, atomic number, electronic structure. Period 4, K. Right? its electronic configuration is 19. So 4 shells are required, K, L, M, N. First shell can hold only 2. 19 minus 2, 17 had 2 registered, 8 in L and M each. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 8, 16 plus 2, 18, and 1 is remaining here. In the same way, you can adjust calcium, make electronic structure of calcium, right? So this was electronic structure of calcium. In last cell, here only one shell, that is valence shell. Here L is valence shell, here M is valence shell, and electron in it are valence electron. It is carrying one electron, that is one electron is valence electrons, one electron is valence electron, one is right. The last shell is called valence electron, valence shell, and electrons there are known as valence electrons. Now from this electronic structure we will move on to the chemical formulae. Now chemical formulae, as we have read earlier, first work done by Dalton for symbols, then Bergelius, right? From that we derived chemical formula, right? So what does this chemical formula of an element show? It shows the actual number of atoms in one molecule of the element, right? Suppose I write here only O. It means one atom of oxygen. Suppose I write O2. It means two molecules of oxygen, not atom, molecules, right? If I write 2O2, it means two molecules of oxygen, right? This O2 denotes molecules, right? This number denotes atom. If I write 2O, only 2O, these are two atoms of oxygen. If I write O3, O2 is only oxygen, then it has O3 means one molecule of ozone. Now oxygen has converted to ozone, right? Understand the difference between how to write atom and molecule? This number denotes molecule, this number denotes atom. But when formula changes, the whole thing changes, right? Now if I write some common elements like hydrogen, helium, oxygen, sulfur, phosphorus, nitrogen, right, and bromine, chlorine. So hydrogen's formula is H2. What would be its atomicity? Its formula is H2. Its atomicity will 2. Helium's only 1. And we will write 1. Oxygen is O2. Its atomicity is 2. Sulfur is S8. Its atomicity is 8. Phosphorus is P4. Its atomicity is 4. Nitrogen is N2. This is its atomicity. Bromine is Br2. Its atomicity is 2. Chlorine is 2. Cl2. Its atomicity is 2. So this atomicity plays an important role. We have to keep in mind, right, while deriving chemical formulas. Now we will again move deep into this chemical formula. So molecular formula what is this molecular formula? Actual number of atoms of different elements present in molecule of the compound, right? So compound is made with the different elements. Simplest example is water. We know it, water. As we are doing chemistry, we will talk in terms of chemistry. So its formula is H2O. From what is formula denoting? H2 is denoting 2. H2 I have already explained to you. This 2 means 2 atoms of hydrogen. O 1 atom of oxygen, right? The number in front of a formula shows the number of molecules. So if I write 2H2O, this number means 2 molecules of water, right? This number show atoms, this number show molecules, right? Similarly, if I write another example, H2 hydrogen and Cl2. So H2 1 molecule of hydrogen, 1 molecule of Cl2 are added. Let's see what happens. H2 plus Cl2, 1 plus 1 2 HCl, right? So this was atom and molecule concept and chemical and molecular formula concept, right? If we further move on to these formulas, Now what you should know further in it, that is valency. So valency is number of electrons an atom can donate or accept. Number of, while forming compounds, electrons are gained or lost. That is based on that is called valency. Valency is how many electrons any element can lose or can donate or can accept. This valency is always a whole number. Right? Generally it ranges from 0 to 4. This valency is a whole number and it ranges from 0 to 4. Right? Now elements with valency 1, C1 are known as monovalent. Right? Valency 2 are divalent. Monovalent example are sodium simple, potassium A, lithium, rubidium. Divalent are Cu, copper, zinc, Mg, magnesium, calcium. Elements with valency 3 are known as trivalent. Right? Trivalent are ferrous and aluminium. 4 are tetravalent. Example carbon and sulfur. Right? Valence electron we have seen in past. Carbon is having 4 valence electron. Right? This was valency. Now you will also have to deal with radicals. Radicals are, a radical is a positively or negatively charged component of a compound which consisting of a single atom or group of atoms. These are radicals. For examples, if we write chloride, how we will write it? Cl minus. If I write bromide, how we will write it? Br minus. Iodide, I minus, and fluoride, F minus. These 4 are very simple radicals. And in simple radicals there is a oxide also. Oxide, O2 minus. And in complex examples there are sulfate, SO4 2 minus, and carbonates, calcium carbonate, CO3 2 minus, right? Copper sulfate, right? These are radicals. Now we will study about losing or gaining of electrons. When a neutral, first of all, cation. What is cation? When a neutral atom enters into a chemical reaction, neutral atom enters in a chemical reaction, it has to do two works. First, it loses its neutral. First of all, it loses its neutral nature. It has to become an ion and becomes ion because of loss or gain of electron. Why it loss or gain of electron? To become stable. To gain stability, it loses or gains electron, right? If it is loses, then it is called cation. When it is losing electron, it is called cation. And when it gains electron, it is called anion. Cation and anion are these. When it is in loss, it is cation. It is gain, it is anion. Right? How? Suppose one atom loses one electron. What does mean? One atom loses one electron. What does it mean? It means, number one, the atom has one electron less than the neutral atom. First of all, when it loses, which shows an increase in positive charge, right? When negative charge is decreased, positive charge increases. Number second, due to increase in positive charge, the atom is known as cation, right? Because it is losing, so it is called cations, right? Now suppose I take an example of it. We have studied sodium. its configuration is 281, 11 atomic number 281, right? Last shell is 1 KLM, it is holding only one electron, valence shell. Suppose this one electron is lost, so this is sodium atom. After losing one electron, it will become, because it is losing, so it is sodium cation. It becomes sodium cation, and when it is losing electron negative charge, its positivity will increase. It will become positive. Here 281, it has lost one. Sodium ion will have, sodium cation will have only 2 and 8. Now its atomic number is 1. Atomic number is 2 plus 8 plus 1, 11. And electrons are also 11. Right? Here atomic number is also 11. But number of electrons is only 2 plus 8, 10. This is the difference between sodium atom and sodium cation. Atomic number are same, lost one electron, right? Total electrons were 11, so it becomes 10. Right? It was all about losing an electron. Now, or cation. Now we will see gaining of an electron. So if an atom gains one electron, what does it mean? First mean the atom has one electron more than the neutral atom. Right? When it is gaining, because it is gaining a negativity, so it's a negative charge which shows an increase in negative charge. First, so due to increase in negative charge, it is an ion. Example, if take example, I take example of chlorine atom. From chlorine atom it will become chlorine anion. Right? Chlorine, it is gaining. Chlorine's electronic configuration is 287, 7 in 7 valence electrons, so it can gain atomic number 17, so 7 protons, 17 protons. Right? Number of protons and electrons are same, 17 protons. Right? If it gains one electron from this, so gain means its negativity is increasing, it will become negative, from positive to negative. So its configuration will become 287, 288, right? But atomic number will same, 17. Now electrons, how many electrons? 18. Now protons will remain 17. Only electrons have changed, protons will remain 17. Right? So this is the effect of losing or gaining an electron. Right, students? Now, if we take some more examples, of combining valency, suppose I write here magnesium. This magnesium atom loses 2 electrons. And oxygen gain 2 electrons. It will become O2 negative. If want to combine them, Mg2 plus O2 negative. Then this 2 plus 2 minus cancelled and product we will get is N0, that is magnesium oxide. Right? Now this was same. If different, suppose aluminium atom loses 3 electrons and oxygen gains 2 electrons. If we want to combine them, Al3 plus O2 negative. Now it was similar that cancelled, but it is dissimilar. So what we do here? So we have to make them stable by, this is 3, this is 2. We will multiply this by 2, 3 to the 6. Now this by 3, 3 to the 6. Make them similar. Right? What we have done? 2 multiply 3 plus equal to 6 positive. Right? We have done here 3 multiply 2 minus equal to 6 negative. Multiplication, this 3 plus this 6 negative. We have to cancel its effect. 6 minus 6 0. So product we will get here would be, we have cancelled their valency. So this will become its molecule Al2, and this will become its molecule O3. Al2O3. Right? This was adjusting of valency. Right? Now one more term is here, variable valency. Variable valency. If any element shows more than, any element show more than one valency. It is called variable valency. So what does it mean? It means that metallic element can lose electron from its inner orbits also. Okay. So for further you will do in your further classes. Here we have to only definition. We have to deal with only definitions. Right? Now you have to keep in mind positive and negative radicals. For that, suppose if we do deal with lower valency of metal ion, if we deal with lower valency of metal ions, we add a suffix, that is os. For higher valency of metal ions, suffix ik is used. Okay, right? Suppose I write lower valency. Here I write higher valency. Fe2 is 2 is lower. So this will be carry suffix Fe ferrous. Fe3 higher. This is ferric. In the same way, ferric. If I write Cu2 plus, Cu plus, sorry, Cu plus one, only one valency, so this is Q plus, QpROES. If I write Cu2 plus higher valency, this will become Q3, right? If I write only Hg plus, this is one mercurous. If I write Hg2 plus, this is mercury. So this was your us and ik formula, right? Now these positive and negative radicals are given in your in given book detail their names, so you can do that from there. Now we will move on to criss-cross method of writing formula. Students, this is an important. So criss-cross method is, we will understand it by example. Suppose I want to write magnesium chloride formula. So in the step 1, write symbol of the positive radical to the left and negative to the right side of a compound. Compound is magnesium chloride. So in magnesium chloride, magnesium and chloride, magnesium is 2 plus positive, chloride is negative. I write it here. Right? Now in step 2, I write this way, Mg2 plus I write here, and chloride I write here. In the same way, this Mg now don't take care of positive or negative signs. Write this way. See here. This will become its here, and these two will its molecule here. Right, irrespective of their positive and negative signs. Now, what I have done, this Mg is going to combine with this. This is crisscross formula. Right, now R is done. Step 3 is of combination. If you understand this easy for you. Now Mg2 plus Cl2, Mg2 plus Cl2, Mg2 plus Cl2. Why I am repeating? Mg, this will combine lower. We will now ignore these positive and negative signs and shift the valency to the lower right side of the radical. Valency, this will shift it to the lower right side of the radical. This is our compound. Right? If we take another example of copper sulfate, blue vitriol sulfate, copper and sulfate. Step 1, you have to learn the positive radicals and negative radicals from your book. Copper Cu2 plus cupric, when it is here it is cupric, more higher valency, cupric Cu2 plus. Now sulfate is negative, SO4 negative. You understand this? Then it is simple. Now we will do Cu2 plus SO4 minus. We will make this cross. From this SO4 you will get Cu2. So SO4 2 negative. So we will overcome its positivity via its negativity of SO4. Right? And this SO4 now will become 2 positive here. Now 2 plus 2 negative has been overcome. So our Cu lower right side valency will shift it to the lower right side, SO4. Now when same valency comes, both valencies get cancelled. Both twos are here, both twos are got cancelled. Right? If we have 2 positive, 2 negative, then both will be cancelled. Right? Now if we do another compound, aluminum chloride, right? We know here aluminum ion is positive, chloride ion is negative. First step. Second step, we will crisscross them, Al3 plus Cl minus 1. Now we will shift this into Al1 and this will be shifted into chloride 3. Now all is done. Al, Cl, Al, Cl is our compound, right? AlCl3 is our compound. Now if we want to write aluminium sulfate, aluminium in the same way, Al3 plus and sulfate is SO4 2, right? Al3 plus SO4 2 negative. So we will total its effect. So this SO4 will be carrying this, and this aluminium will be carrying this, irrespective of their sign. So now our compound will be Al2 SO4 twice. No need to panic. Right? Now if we take another example, ammonium phosphate. Ammonium ion is NH4 1 plus and phosphate is PO4 3 negative, right? Now next step, NH4 1 plus PO4 plus 3, right? Now this will become PO4 1, no need to write 1, and this will become NH4 and this will come here. Now we can combine it, NH4 twice PO4. So students, this was your chapter of atomic structure. Do it carefully, it is very important from a chemical point of view. If you understand this, please like, subscribe and share, and get subscribed to your friends, other students, so that they can also be helped. Then it's goodbye. We will meet in the next video with some next topic. Thanks. Goodbye.